Today I'd like to take a look at a topic called clock or modular arithmetic. Now what you see before you obviously looks like a clock face, except there's something a little different about it, and that is the fact that there is the number 0 up there in place of the number 12. Well, modular arithmetic is exemplified perfectly with the hour hand of a clock, except the clock goes to 12 instead of having a 0 on it. So what you have to realize is that the time 12 is actually just like the time 0 in a modular arithmetic clock. So let's pretend right now that the time is 2 o'clock. So if the time is 2 o'clock, that would mean I would have the hour hand facing the 2, like so. So if the time right now on our particular clock reads 2, what time is it 12 hours from now? Now we must remember that in a modular arithmetic clock, we are never concerned with AM or PM. So what time will the face of the clock hour hand read 12 hours from now? Well, if you think about that, that's a fairly simple problem, because we know it's going to be 2 o'clock, right? Because 12 hours from 2 o'clock would once again be 2 o'clock. Let's look at it mathematically, though. If we take the time 2 and we add 12 to it, we obtain 14 o'clock. But how do I convert 14 o'clock into a modular 12 system? Well, just divide by the mod number 12. And since it's a mod 12 clock, even though it shows 0 at 12, we divide 12 into 14. It goes once with a remainder of 2. Notice the remainder is the answer to the problem in mod 12. Let's back up for a couple of minutes and take a look at why dividing by the mod system we are in gives us the answer we're looking for as the remainder. What time would this clock say if it was 42 o'clock? Well, if we take 42 and divide it by 12, notice it goes 3 times. 36 is the number we would get here, with a remainder of 6. Why is the remainder of 6 the time we're looking for? Well, have you ever heard of casting out 12s when you divide? So to locate our time on this clock, let's assume we're at 0. If we're at 0 and we were to move around 12 moves on the clock, we would be back at 0. And if we did it a second time, 12 moves from 0, we would end up back at 0. And if we did it a third time, 12 moves would take us again back to 0. So notice we've cast out 3 12s by multiplying 3 times 12 and getting 36. The leftover amount is 6. So we would have to be 6 moves away from 0. That is why the time would be 6 o'clock. All right, let's stay with our idea of 2 o'clock again. What time is it 17 hours from 2 o'clock? Using the same process, we simply would take the current time, 2, add 17 to it. We would get 19 o'clock. If we take 19 o'clock divided by the mod number the clock arithmetic is in, 12, it goes once, 12, with a remainder of 7. By the way, we could count this out. We actually could go 17 hours ahead of 2 and see if we do come out with 7 o'clock. Let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 hours after 2 is 7 o'clock. Now here's something else we could do. Instead of adding 17 hours to 2, we could first convert 17 hours to a mod 12 number. To take 17 and convert it to a mod 12 number, we simply divide by the mod number 12. It goes once with a remainder of 5. So if I take the time 2 o'clock and add to it 5 hours, which is the same thing as adding 17 hours, notice I obtain the answer 7. Well, let's try a different modular system. Okay? Our last clock was mod 12. What mod is this clock? Well, it goes from 0 to 8, but 0 is the same thing as 9, right? So this is a mod 9 clock. Notice it says the time is 5 hours. All right? What time is it 23 hours from now? Okay, so if I take 5 hours and add to it 23 hours, I get 28. I want to convert 28 into a mod 9 number. Therefore, I divide it by 9. Notice it goes 3 times. So that's 27 with a remainder of 1. So our time should be 1 hour, or just the answer 1. If we wanted to count 23 hours ahead on this clock, we would find you would get 1. Now, of course, I could have done this by first taking my increase in time, 23 hours, and have converted that to a mod 9 number. So let's try that. If I take 23 and convert it to a mod 9 number to start with, okay, it goes in twice, 18, with a remainder of 5. So if I take my original time, which is 5, and I add to it 5 hours, notice I get the answer 10. Well, 10 is obviously larger than mod 9, so I'm going to take 10 and convert it to a mod 9 number. 9 goes into 10 once, with a remainder of 1. So you can see I get the answer no matter which way I decide to do it. I can work the numbers out that are given to me, or I can convert everything to the mod involved and do any conversions that are necessary as I go along. Okay, let's take our mod clock and let's do a little harder question. If the time right now is 5 and I increase it by 12 to the 3rd power, what time will it be? Okay, well, I have some choices here I can make. Since 12 is larger than a mod 9 number, we could convert 12 to its mod 9 equivalent before we cube it. So let's see, what would that be? Well, 12 divided by 9 goes once, remainder of 3. So this is the same thing as 3 to the 3rd power. Now, if this is 3 to the 3rd power, we can evaluate that. That would give us 5 plus 3 to the 3rd, which of course is 27. But wait a minute, 27 is larger than a mod 9 number, so let's convert it. Well, let's see. What is 27 divided by 9? Goes 3 times, exactly 27, and we get the answer 0. So it appears then that we only have to add 0 to 5 to obtain the answer that the time will be 5. So the answer is actually 5 mod 9. What if we, instead of doing the conversions of taking the number 12 and making it a mod 9 number first, what if we had just taken 12 to the 3rd power and evaluated the problem that way? Well, it would have been a little harder, but we should get the same thing, so let's just test it out. So if we do 5 plus 12 to the 3rd, 12 to the 3rd is 1728. If I take 1728 and divide it by 9, goes once, 9, 82, this is an 8 here, okay, this goes 9 times, 81, I get 18 down here, and notice my remainder is 0. So 1728 would have come out 0 anyway. So 5 plus 0 still gives us the answer that the time would be 5 mod 9. Let's take a look at a little bit different kind of problem. Is the statement that you see before you a true statement? If you take 4 to the 5th power, add to it 2 times the quantity 12 minus 3, is that answer identical to 3 mod 6? Let's give it a try. I could attack this problem in a couple of different ways. One way is to simply just work out the left-hand side of the sentence and see if we do indeed end up with 3 mod 6. So let's try that first. If we went to a calculator and evaluated 4 to the 5th power, we would get 1024. Continuing to evaluate the expression, 12 minus 3 I would do first since it's in the parentheses. That gives us 9. And of course, 2 times 9 would give us the value 18. So is 1,224, is 1,024 increased by 18 the same thing as 3 mod 6? Well, let's add these two together. When you do, you obtain 1,042. Well, all we need to do is to take 1,042 and convert it to a mod 6 number by dividing by 6. Now remember, you want to do this longhand because you do not want to do it by calculator, because you will get a decimal answer perhaps, and that doesn't help us get the remainder, which gives us the correct answer in the correct mod. So I get 44 here. 7 times 6, of course, is 42, with a remainder of 22 here, or a remainder of 2, which becomes 22. 3 times 6 is 18. So as you can see, my remainder is 4. So this number actually comes out to be 4 mod 6, and 4 mod 6 is not equal to 3. So we simply put a slash through this, showing that these two are not indeed the same. Is this the only way we could do this problem? Well, no, it's not. For the 5th power, we would still have to do 1,024. But we could take the 12 that is here and change it to a mod 6 number. Notice I get 0 for it. Inside we have a negative 3 then. So what is 2 times negative 3? Well, of course it's negative 6. So if I take 1,024 and subtract from it 6, will I get the same answer that I did before, 4 mod 6? Well, let's see. 1,024 minus 6 is 1,018. So let's convert 1,018 into a mod 6 number. 1, 6, 41. 6 times 6 is 36. 58 we get here. 9 times 6 is 54. And of course the remainder I obtain is 4. So in both cases, no matter which way I attack the problem, I will obtain 4 mod 6, not 3 mod 6. Let's quickly try another example. This is a similar problem, and we can do it again in one of two methods. Let's just work out the left-hand side quickly first and see what we get. 7 to the 4th power is 2401. If I add to that 12 times 9 minus 3, which of course is 6, will I obtain 2 mod 5? Well, let's see. 2401 plus 72. So if I do 2401 plus 72, I get 2473. Is that 2 mod 5? Well, if I take 2473 and divide it by our mod number 5, what do I obtain? It appears that I'm going to be getting 3 mod 5 rather than 2 mod 5. So we end up with 3, which is not identical to 2 mod 5. Now let's instead work through the problem by changing any numbers which are larger than 5 into mod 5 numbers and work the problem out that way. It should be a little easier perhaps. So let's see, the 7 under 7 to the 4th power, well, let's see, what would 7 become? 7 would simply become 2. So we're going to have 2 to the 4th power. And we're going to increase that by, let's see, what is 12 mod 5? Goes in twice, 10, remainder 2. So it is 2 times the quantity. Well, what is 9? Well, 9 becomes 4. So we'll replace the 9 with a 4, minus 3. And what do we obtain here? Well, let's see. 2 to the 4th power, I believe, is 16. And if we evaluate this, 4 minus 3 is 1. 2 times 1 is 2. We obtain 18. Well, let's see. What is 18 written as a mod 5 number? Well, to divide 18 by 5 goes 3 times with the remainder of 3. So once again, we obtain the fact that this expression is 3 mod 5 rather than 2 mod 5. I am thinking that you might be thinking, what in the world would we ever use this type of clock or modular arithmetic for? Well, before I actually show you some uses of it, what I would like to do is take a look at a special modular system, that being mod 10. It's nothing particularly special, except it's kind of easy to work with. Let me ask a couple questions. What is the answer to 28 written as a mod 10 number? So 28 is identical to what number mod 10? Well, if we take 28 and we divide it by the mod number 10, notice it goes twice, and the remainder I get is 8. So this happens to be 8 mod 10. Okay, what is the answer to 14 written as a mod 10 number? Okay, let's see. If I take 14 and I divide it by 10, it goes once, 10 with a remainder of 4. So this turns out to be 4 mod 10. From just the two examples I have completed, can you tell me what you think 37 will become as a mod 10 number? Well, you've probably already discovered how it works. Notice if we take 37 and divide it by 10, we get a remainder of 7. And you'll notice there's a 7 here. Notice the 14 gave us a 4 here. Notice that the 828 gave us the answer 8. So all you have to do to convert a number into a mod 10 number is simply throw away all the digits except for the units digit. Remember, this is called the tens digit right here. This is the units digit right here on 28. All right? So all we have to do is throw away the rest of the numbers and just take the units digit, and that's what it is, mod 10. So 726 written as a mod 10 number is simply 6 mod 10. 142 is 2 mod 10. 79 is the same thing as 9 mod 10. And also notice that if you want to have the answer come out 0 mod 10, our number in question just has to end in a 0. For example, 30 is 0 mod 10, 40 is 0 mod 10, 50, 60, 70, 80, 120, 3050, all of those numbers are 0 mod 10 because their units digit is 0. In fact, if we think about it, any number that ends in 0 is a multiple of 10. So any multiple of 10 written as a mod 10 number is simply 0. In our next video, we are going to take a look at a very interesting use of modular 10 arithmetic that is used all around us every day that you never even think about. So this is the introduction you needed to help you understand how the mod 10 system works in our everyday lives. See you there.